Digital systems power our world, from smartphones to satellites. Designing these systems requires specialized skills in hardware description languages and digital logic. Verilog HDL is the industry standard for ASIC and FPGA design, but mastering it requires more than learning syntax. It requires understanding how to think in hardware, write synthesizable code, and verify complex systems. This course provides a comprehensive foundation in digital design using Verilog. It's structured as a systematic progression from fundamental concepts to advanced system implementation. You learn through practical application, with each module building directly on the previous one through lectures, hands-on labs, and project assignments. We begin with Verilog fundamentals, module structures, data types, and procedural blocks. We then explore critical design patterns including finite state machines, parameterized modules, and memory structures. Importantly, we address common pitfalls like simulation races, unintentional latches, and timing issues that often challenge beginners. Your learning will be passed through practical implementation. You'll design simulation and verify a 16-bit ALU, arithmetic logic unit, an 8 times 16 register file, linear feedback shift registers, and finite state machine controllers. These projects mirror real-world design challenges and form a professional portfolio demonstrating your capability to implement complete digital systems. This course is designed for engineering students, early career professionals, and those transitioning to hardware design roles. Upon completion, you'll possess the skills to write production-ready Verilog, develop verification test benches, and contribute meaningfully to ASIC or FPGA design teams. This is where theoretical knowledge meets practical implementation. Thanks for watching.